What if I told you that the brightly colored, fruit-flavored yogurt that you might be feeding your kids literally right now,
Right.
the exact one that is explicitly marketed to you for its gut health and probiotics? What if I told you it contains synthetic chemicals that are actively murdering those beneficial bacteria before you even peel back the foil lid?
Wow. Yeah.
Welcome to the deep dive. If you're listening to this on your morning commute, or maybe you're just, standing in your kitchen trying to figure out what to eat, the universal struggle of breakfast.
Oh, absolutely.
Right. I mean, you want something fast, you want something affordable, and you desperately want it to not actively destroy your metabolism.
It really is the ultimate modern tug of war. Like, we have this biological imperative to fuel ourselves, right?
Right.
But we're doing it in this entirely engineered food environment.
Yeah.
And it makes the simple act of eating breakfast feel like, honestly, navigating a minefield.
Exactly. I mean, you're just trying to optimize your routine. You want energy that actually lasts past like 10 a.m., but you don't want to feel overwhelmed by the absolute avalanche of contradictory health advice out there. And you certainly don't want to eat food that tastes like salted cardboard.
Right, which is usually the alternative. Right.
Exactly. And that is our mission today. We are pulling really heavily from a fascinating concept laid out by Gary Brecka. This is from episode 50 of his Ultimate Human Deep Dive.
Yeah, the lateral shift.
Right. He introduces this framework called the lateral shift. And the promise here is, honestly, it's massive.
It really is.
It's about transforming a highly processed, standard American breakfast into a nutrient-dense powerhouse. But, and this is the key, without adding a single dime to your grocery budget.
And without changing the flavor profile.
Yes, without changing the flavor profile.
Which is such a vital distinction, because the fatal flaw of almost every nutritional intervention or like diet fad is that demand for a total lifestyle overhaul.
Oh, completely. It's always like, throw out your whole pantry.
Exactly. But Brecka's lateral shift isn't about becoming a raw food vegan overnight, right? It's the deliberate strategy of looking at the exact foods you or your family already crave.
The crunchy cereal, the sweet yogurt.
Exactly, the creamy milk.
Yeah.
And you simply swap the heavily processed, chemically engineered version for a highly nutrient-dense equivalent.
Okay, wait, hold on. Because I have to push back on this a little bit.
Sure.
If I swap out my kids', neon-colored, sugary cereal for something made of chickpeas,
Yeah.
there is no way it's going to have that same aggressive, satisfying crunch. And it's definitely not going to taste like the cereal I grew up with. I mean, how is it physically possible to keep the exact same flavor profile without the laboratory engineer?
It sounds too good to be true, right?
It really does.
It sounds impossible until you look at the mechanics of satiation in food science, which Brecka unpacks beautifully in the source material.
Okay, break that down for me.
So, when you consume heavily processed foods, you're eating products specifically engineered for hyperpalatability. They use refined sugars and synthetic flavorings to just light up the dopamine centers in your brain.
Mm-hmm.
But structurally, they're completely devoid of actual nutrition.
So it's just empty volume.
Exactly. They're empty volume. Your stomach might be physically stretched, but your cells are essentially starving.
Wow.
So your body never sends the "I'm full" signal.
So your brain just keeps telling you to eat because it's like frantically searching for actual vitamins and minerals in this bowl of empty carbs.
Precisely. You're overeating because you're undernourished.
That makes so much sense.
But when you execute a lateral shift to a food that is significantly more nutrient-dense,
Yeah.
even if it mimics the exact same sweet and crunchy profile, a profound physiological shift happens.
What happens?
You inherently consume fewer calories because your digestive system actually registers the incoming protein, the healthy fats, and the complex carbohydrates.
Oh, okay.
It signals the vagus nerve and releases leptin, which is the satiety hormone.
Right. Leptin tells you you're full.
Exactly. So the lateral shift works because you aren't tricking the taste buds. You are genuinely satisfying the body's chemical requirements.
Which is such a relief, honestly, because you don't have to fight your cravings. You just have to give your body a better version of what it's asking for.
Right. Work with the body, not against it.
Exactly. But I feel like to truly appreciate the value of this shift, we have to get a little uncomfortable.
Yeah, we have to look at the baseline.
Right. We need to look at the baseline we are shifting away from. We need to deconstruct the cereal aisle.
Oh, man. It is the cornerstone of the standard American breakfast. We're talking about ubiquitous pantry staples.
White bagels, Pop-Tarts.
Yep, and those brightly colored, heavily marketed cereals, your Fruit Loops, your Honey Nut Cheerios. Brecka breaks down the macronutrient math on these, and
Yeah.
the reality is staggering.
It really is. Let's look at those numbers for a second. In a single theoretical serving of these legacy cereals, you are looking at roughly 34 grams of carbohydrates.
Which is a lot.
It's massive. And nested within that, anywhere from 12 to 21 grams of added sugar.
Right. And that's just the theoretical serving.
Exactly. Who actually eats the theoretical serving size printed on the side of a cereal box?
Basically nobody. It's usually a half cup.
Right, which brings us to the reality of human behavior. Brecka rightly points out that a real-world bowl-like, the amount a busy parent actually pours into a bowl before school, is almost universally 2 servings.
Easily. So before 8 a.m., you were ingesting nearly 70 grams of highly refined carbohydrates.
Wow.
And potentially over 40 grams of added sugar. To put that in perspective, that is like a flash flood of glucose hitting your bloodstream.
It's an emergency for the body.
It is. Your pancreas basically has to panic and dump massive amounts of insulin just to handle it.
But it's not even just the sugar, right? When Brecka deep dives into the actual ingredient list, it starts to look less like a breakfast and more like an industrial chemistry experiment.
Oh, completely. Let's start with the visual appeal, which is entirely manufactured. Right. The ingredient lists on these boxes proudly display synthetic dyes.
Yeah.
Yellow dye number 1, yellow 6, yellow 5, and red dye number 40.
And these are synthetic.
Yes, these are petroleum-derived synthetic compounds. And they're used for one reason only: to create a vibrant, uniform, unnatural color palette that catches a child's eye from the grocery store aisle.
From 20 feet away.
Exactly.
And then you have the preservatives, things like BHT, which is butyl hydroxytoluene, I think, added to preserve freshness.
Yeah.
And then sodium lauryl sulfate. When I read that in the source, my jaw literally dropped.
Shocking.
Because if I pour sodium lauryl sulfate into a bowl, I'm usually manufacturing a batch of cheap Motel soap or like heavy-duty shampoo.
Right, it's a degreaser.
It's a foaming agent and an emulsifier. Why on earth is it in a child's breakfast cereal?
Well, it speaks to the logistical requirements of mass food production. These ingredients, they aren't added for human nutrition. They're added to solve supply chain problems.
Okay, explain that.
Manufacturers need that cereal to survive the manufacturing extruder, right? Then sit in a warehouse, travel across the country in a sweltering truck, and then sit on a grocery store shelf for 18 months without degrading or losing its texture.
So they're building a highly stable plastic, essentially.
Basically. And the fats they use follow the exact same logic. Brecka notes that to achieve that specific shelf-stable crunch, they use highly processed seed oils.
Right.
We're talking partially hydrogenated soybean oil, partially hydrogenated coconut oil, partially hydrogenated vegetable oil, and canola oil.
And hydrogenation is essentially the process of forcing hydrogen gas into liquid oils at high pressure, right? So they become solid at room temperature.
Exactly. It makes them incredibly stable.
It's completely unnatural for the human body to actually process.
Unnatural and harmful.
Mm-hmm.
It creates trans fats and heavily oxidized lipids that actively drive cellular inflammation.
Wow.
But, and this is the tricky part, manufacturers mask this incredibly poor nutritional profile through a process called fortification.
Oh, yes. The bright, bold letters on the box.
Right. You'll see fortified or enriched, which creates this false health halo around the product.
All right. Enriched with 11 essential vitamins and minerals. It sounds like a multivitamin. Like you're doing a good thing.
But Brecka details what that fortification actually looks like on a biochemical level.
Yeah.
And it's not pretty.
No, it's not.
First, the grain, usually wheat or corn, is heavily refined. They strip away the bran, the germ, the fiber, all the naturally occurring nutrients.
That's just dead starch.
Dead starch.
Yeah.
Then they spray it with synthetic lab-created vitamin replacements. And one of the primary ones they use is folic acid.
Okay, and here is where we get into some truly fascinating biology, because Brecka points out a massive issue with synthetic folic acid regarding something called the MTHFR gene mutation.
Yes.
What exactly is going on here?
So this is a really crucial piece of the puzzle.
Yeah.
MTHFR stands for methylene heterofolate reductase.
That is a mouthful.
It is. But basically, it is an enzyme in your body responsible for a vital process called methylation. Simply put, its job is to take folate, which is the natural form of vitamin B9 found in things like leafy greens, and convert it into an active form that your cells can actually use for DNA repair and energy production.
Okay, so folate is the natural stuff. MTHFR is the enzyme that processes it.
Exactly. Now, according to the source, an estimated 30 to 40% of the population has a genetic mutation in this MTHFR gene.
Almost half the population.
Right. Meaning their enzyme is sluggish. It operates at a significantly reduced capacity.
Okay.
And here is the problem Brecka highlights. Folic acid is not folate. Folic acid is a synthetic, entirely man-made molecule.
Ah.
When you consume foods heavily fortified with synthetic folic acid, your body still has to use that sluggish MTHFR enzyme to try and process it.
So if your enzyme is already slow and you dump a massive amount of synthetic folic acid onto it from a bowl of enriched cereal, what happens?
It basically causes a metabolic traffic jam.
A traffic jam?
Yeah. The unmetabolized synthetic folic acid just builds up in your bloodstream. And worse, it actually binds to your cells' folate receptors, blocking them.
Wait, so it blocks the receptor?
It takes up the parking spot. So even if you eat a healthy spinach salad later in the day, the natural folate can't get into your cells because the synthetic folic acid from your morning cereal is hogging all the parking spots.
That is incredible, and honestly a little terrifying.
It is.
That 40% of people might be walking around with this mutation, eating fortified cereal every morning and wondering why they feel lethargic.
Right, because this backup agitates the system and can lead to a host of inflammatory and energy-related issues.
And Brecka mentions another synthetic vitamin sprayed on these cereals that caught my attention, the B12.
Oh, yeah. The specific form of vitamin B12 used in mass-market fortification is cyanocobalamin. And as Brecka explicitly identifies in the deep dive, this is a cyanide-based form of B12.
Okay, let's pause there. Cyanide. Like the poison.
Yes, exactly like the poison.
Why would anyone attach a cyanide molecule to a vitamin? That sounds insane.
It sounds insane, but it comes entirely down to cost and chemical stability.
Okay, explain that.
So the B12 molecule have a cobalt atom at its center. That's the cobalamin part. In nature, it's usually down to a methyl group, making methylcobalamin
Which your body can use instantly.
instantly. But methylcobalamin is sensitive to light and temperature, which makes it expensive for mass food production.
Oh, of course.
So laboratories synthesize B12 by attaching a cyanide donor molecule to the cobalt. The cyanide stabilizes the vitamin perfectly so it can sit in a silo for years.
But what happens when a human being actually eats it?
Well, your body obviously does not want cyanide floating around.
Right.
So your liver has to intercept this synthetic vitamin. It has to sever the cyanide molecule, and to safely excrete that cyanide through your urine, your liver has to expend a methyl group to bind to it.
Wait, really?
Yeah, so consuming this cheap form of B12 actually taxes your body's metabolic resources just to make the vitamin usable.
So it's a net negative. You're paying a metabolic tax just to process the cheap vitamin they sprayed on your processed wheat to make it look healthy?
Exactly. And to top it all off, we have the phrase natural and artificial fruit flavoring.
Oh, yes. Which Brecka dryly translates as industry code for ain't got no fruit.
It is purely synthesized chemistry to match the synthetic dyes. Now, it's important to remember that we aren't presenting these metabolic mechanics to fearmonger, right?
No, absolutely not.
We're just impartially laying out the exact scientific rationale Brecka uses to justify his lateral shifts. He's pointing out that this standard breakfast is engineered for the supply chain, not the human digestive system.
Okay, so if we are throwing out the sodium lauryl sulfate, oxidized seed oils, the metabolic traffic jams of folic acid, and the cyanide-laced vitamins.
All the fun stuff.
Right. What actually replaces it? How do we find a swap that tastes the same, has that same crunch, and doesn't cost an arm and a leg?
Well, this brings us to the execution of the cereal shift. Brecka highlights specific alternatives that represent optimal lateral shifts.
He names a couple of brands, right?
He does, specifically naming brands like Three Wishes and Rise and Fly. And the critical detail he notes up front is the economic factor.
Which is huge for families.
Exactly. These grain-free alternatives cost the exact same price as the heavily processed legacy brands we just dissected.
That's amazing. And the ingredient legibility is what blows my mind here. Let's look at Three Wishes first.
Yeah, let's look at it.
There is no list of unpronounceable industrial chemicals. The base is made entirely from chickpea, tapioca, and pea protein.
And look at the macronutrient shift. By utilizing pea protein in chickpeas instead of refined wheat, the carbohydrate count drops from that massive 34 grams down to 20 grams.
That's a huge drop.
And the added sugar plummets from 12 grams down to just 3 grams.
Wow.
And rather than utilizing petroleum-derived red dye 40, they use simple vegetable juice for color and monk fruit for additional sweetness.
And Rise and Fly is even simpler. The ingredient list reads like a grocery list you could actually shop for.
It really does.
It's just cassava, coconut, honey, coconut sugar, cinnamon, coconut oil, and Himalayan salt. That's it.
It's beautiful.
But here is where I have to ask the practical question. I know the chemistry of wheat. Gluten creates a structural network that traps air, which is why a traditional cereal has that perfectly aerated, shattering crunch.
Right.
Can a root vegetable like cassava actually mimic the structural crunch of a neon grain loop?
It's a brilliant question because texture is usually the downfall of the healthy swap.
Oh, absolutely. Usually it's like chewing on cardboard.
Exactly. But the food science here is fascinating. Cassava and tapioca, which is derived from it, are incredibly starchy root vegetables.
Okay.
They don't have gluten, but they possess a massive amount of amylopectin, which is a highly branched starch molecule.
So how does that create crunch?
When you cook cassava starch and then rapidly cool it, which is essentially what happens in a cereal extruder, it undergoes a process called starch retrogradation.
Retrogradation.
Yes. The molecules realign into a highly rigid, almost glass-like structural matrix. When you bite into it, it shatters perfectly. It mimics the aggressive, aerated crunch of traditional processed grains beautifully. But it does so without the inflammatory proteins and gluten associated with highly refined wheat.
That is incredible. Okay, but what about the sweetness?
Well, the natural ingredients like organic honey and coconut sugar provide a very familiar, immediately recognizable flavor profile. But the magic is in the combination.
How so?
Because those natural sugars are structurally paired with the complex carbohydrates of the cassava, the pea protein, and the healthy fats from the coconut oil, your metabolic response is fundamentally altered.
Because it takes the body longer to break down the protein and the fat, right?
Exactly. Instead of that flash flood of glucose we talked about earlier, it's more like a slow, deliberate drip irrigation system.
That's a great analogy.
The digestion is slower. The insulin spike is radically blunted. This is the definition of a true lateral shift.
Right, because the sensory experience of eating a crunchy, sweet bowl of cereal remains perfectly intact, but the biological aftermath is completely transformed.
You're moving from a biological emergency to a state of sustained nourishment.
Okay, so the dry component is fixed. We've laterally shifted the cereal. But nobody eats dry cereal.
No.
To complete the bowl, we have to talk about the liquid we pour over it. And Brecka has some very strong, specific views on rethinking the dairy dilemma.
He really does. He advocates for a deliberate step away from the standard cartons of mass-market pasteurized, homogenized milk.
Okay.
Instead, the text presents two very distinct lateral shifts for the liquid component. The first one is quite specific: raw A2 dairy.
Right. And he suggests sourcing this from local grocers, farmers markets, or Amish farms if you can. Now, the term raw milk is highly controversial.
Controversial.
But the crucial part of Brecka's argument actually hinges on that A2 designation. He claims that raw A2 dairy has significantly lower levels of a protein called beta-casein.
Right, which he identifies as a primary culprit in gut irritation.
So break that down for me. What is A1 versus A2?
Well, to understand Brecka's rationale here, we need a brief dive into the history of bovine biology.
Let's do it.
Cow's milk contains proteins, and one of the major ones is beta-casein. Thousands of years ago, all cows globally produced a specific variant of this protein called A2.
Okay.
However, a genetic mutation occurred centuries ago in European herds, specifically in breeds like the Holstein, which are the classic high-yield black and white cows used in modern commercial dairy.
And that mutation created the A1 protein.
Exactly. The mutation changed a single amino acid in the protein chain. So modern commercial milk is predominantly A1 milk.
Got it. So why does that matter for our gut?
Here is the physiological issue Brecka is highlighting. When human digestive enzymes break down A1 beta-casein, they cleave it at that specific mutated amino acid, releasing a peptide fragment called BCM7.
Which stands for?
Beta-casomorphin 7.
Casomorphin, that sounds like morphine.
That's because it is an opioid peptide.
Wait, really?
Yes. When BCM7 hits the human gut, it can bind to opioid receptors, slowing down gastrointestinal motility and triggering localized inflammation and histamine release.
So when people drink a glass of standard grocery store milk and feel bloated, cramped, or congested, they automatically assume, I'm lactose intolerant.
Right. But Brecka's perspective is that for a significant portion of the population, it isn't the lactose, the milk sugar, causing the issue at all.
It's the protein.
It is the inflammatory response to the A1 beta-casein breaking down into BCM7.
Okay, so how does shifting to A2 fix this?
By shifting specifically to A2 dairy, from heritage breeds of cows or goats or sheep, that specific peptide isn't released during digestion.
Because it doesn't have that mutation.
Exactly. The text argues that this makes A2 dairy highly tolerable for people with perceived slight dairy intolerances.
It's important to note that the pasteurization versus raw milk debate is a fiercely contested issue in broader public health circles.
Oh, absolutely.
But within the strict context of Brecka's lateral shift framework, the emphasis is heavily on avoiding the enzymatic breakdown of that A1 protein to preserve gut health.
Precisely. We are just mapping his specific architectural blueprint for this swap.
Now, for those who simply cannot source raw A2 milk, or maybe they just prefer to stay entirely plant-based, Brecka offers a second lateral shift.
Yes.
Organic light coconut milk, specifically the unsweetened version in a carton, not the heavy canned stuff.
And the beauty of this is its utter simplicity. The ingredient list is literally purified water and organic coconut.
That's it.
That's it. From a macronutrient perspective, a serving yields about 3.5 grams of healthy fats with absolute zero carbohydrates and zero sugars.
But here's where reality hits the kitchen counter. I've poured unsweetened coconut milk before.
Yeah.
It is very thin, and it has almost zero inherent sweetness. If I am using entirely unsweetened coconut milk and I am pouring it over a grain-free cereal that has already slashed its sugar content from 12 grams down to 3 grams,
I see where you're going.
aren't my historically sweet cereals going to taste like a puddle of vaguely coconut-flavored water? Where's the joy in that?
It's a highly practical concern, right? If you remove all the sugar, you remove the palatability for most kids. But Brecka anticipates this with a remarkable, elegant hack. If the lateral shift to unsweetened milk leaves the bowl lacking the sweetness you desire, you don't abandon the shift and go back to the Fruit Loops. You
Right.
simply add a single spoonful of monk fruit directly to the bowl.
We need to talk about monk fruit because it is the secret weapon in this entire deep dive. What exactly is it?
Monk fruit, scientifically known as Serratia grovenori, is a small green melon native to Southeast Asia.
Okay.
What makes it unique is that its intense sweetness doesn't come from fructose or glucose like other fruits.
Really? Then what makes it sweet?
The sweetness comes from unique antioxidants called magrosides.
So it's sweet, but it's not a sugar.
Exactly. When you consume monk fruit extract, those magrosides bind perfectly to the sweet taste receptors on your tongue, registering a profoundly sweet flavor to the brain.
But it doesn't act like a sugar in the body.
Right. Because it isn't a carbohydrate, it passes through the digestive system without ever entering the bloodstream as glucose. It yields 0 calories and causes an absolute 0 spike in insulin.
It is brilliant. By utilizing the unsweetened coconut milk and adding the monk fruit manually, you take the control back.
You're in charge of the macros.
Exactly.
Yeah.
You aren't relying on a manufacturer who has dumped massive amounts of high fructose corn syrup into a vat to guarantee a cheap sugar rush.
Right.
You get the healthy fats from the coconut milk, the satisfying complex crunch from the cassava cereal, and the exact level of custom sweetness you want with literally none of the metabolic damage.
You've successfully completely re-engineered the cereal bowl.
Which is huge. Cereal and milk is the classic frantic morning staple. But we need to pivot.
Let's do it.
Because many parents, and frankly many health-conscious adults, reach for something else entirely during the morning rush.
Yeah.
They reach for something they inherently assume is already the ultimate health food. Yogurt.
Oh, the yogurt aisle.
Right. But Brecka pulls back the curtain on the commercial yogurt aisle, and what he reveals is a massive, almost unbelievable hidden contradiction.
This is arguably the most critical revelation in the entire source material. We have to examine the highly processed, heavily marketed yogurts, particularly those targeted at children.
Right.
Brecka specifically names products like the beech nut banana and strawberry blends, or those Chobani flip-style yogurts where you fold crunchy bits into the dairy.
The public perception, the entire marketing halo around these products is that yogurt equals health. It equals living probiotics, calcium, and a happy gut microbiome.
But the macronutrients tell a wildly different story. Brecka notes how incredibly deceptive these tiny, brightly colored containers can be.
Let's hear the numbers.
A single small serving of these commercial kids' yogurts can contain an astonishing 30 grams of carbohydrates.
In a tiny cup.
And within that tiny cup, up to 13 grams of pure sugar.
It's basically liquid candy at that point.
It really is. And beyond the sugar load, we have to look at the structural additives. Brecka lists the common ingredients found in these popular brands to maintain their texture.
What are we looking at?
Various animal gelatins, modified cornstarch, potassium sorbate 80 as a preservative, and those fortified, crunchy ingredients you flip into the cup.
Which, as we established in the cereal breakdown, are almost always derived from highly processed, heavily extruded wheat, which acts as a primary gut irritant.
Exactly.
So you are taking a food explicitly designed and marketed for gut health and actively adding structural gut irritants to it.
It makes no sense. But the sugar and the wheat aren't even the wildest part.
No.
The absolute bombshell insight in this deep dive is the chemical interaction between the artificial food dyes used to color the yogurt and the probiotics themselves.
Yes, this blew my mind.
It is a profound biological contradiction that most consumers are completely unaware of. Brecka explicitly states that artificial food dyes are naturally antimicrobial.
Wait, antimicrobial, meaning they kill bacteria.
Correct. Their specific chemical structures actively disrupt and fight bacterial cell growth.
Which means the very synthetic dyes, the bright neon pinks, the vivid yellows that manufacturers use to make the yogurt look fun and appealing to children
Yeah.
are actively murdering the living probiotics that the yogurt is supposed to be delivering in the first place.
Precisely. You are paying a premium for a product specifically for its bacterial benefits, but the aesthetic, petroleum-based modifications of that product neutralize those exact benefits before you even purchase it.
That is wild. That is literally like hiring a highly trained, incredibly expensive bodyguard to protect your home.
Right.
And the second he walks through the front door, you lock him in the soundproof basement where he can't do anything.
That's a perfect analogy.
What is the point? The health food industry markets the bodyguard to you, but the neon coloring is assassinating the bacteria before you even peel the lid back.
If we connect this to the bigger picture, it perfectly illustrates the tragic irony of the modern processed health food industry.
It really does.
The consumer is genuinely trying to make a good choice. A parent buys that specific yogurt because they want their child to have a healthy gut.
Of course they do.
But because of the mass market formulation, it is a metabolic disaster. The massive sugar load spikes the child's insulin immediately.
Right.
And as we know, an aggressive insulin spike is inevitably followed by a steep insulin crash, which triggers the brain to release hunger hormones.
So the child is starving an hour later.
Yeah.
And cranky.
Exactly. Not only are the artificial dyes rendering the probiotic benefits completely useless, but the macronutrient profile guarantees that the consumer will experience a mid-morning crash.
It's perpetuating a relentless cycle of overeating and fatigue.
It is a completely self-defeating product.
You are eating brightly colored, empty sugar paste that murders its own probiotics.
Pretty much.
So, if commercial fruit yogurt is essentially a scam masquerading as a health food, how do we rebuild it? How do we execute a lateral shift to create a yogurt bowl that actually does what it is biologically supposed to do?
Brecka provides a meticulous, layer-by-layer blueprint for what we might call the ultimate satiety bowl. It is a specific lateral shift recipe designed to maximize metabolic stability.
I love this. Let's build it. Layer one.
We start with the base. Brecka recommends completely swapping out these sugary dyed cups for a base of non-GMO, organic A2 whole-fat Greek yogurt.
Okay, so again, the emphasis on A2 dairy is to bypass that gut-irritating beta-casein breakdown we discussed earlier.
Right.
And the emphasis on whole fat is critical here.
Very critical.
Yeah.
Because we've spent the last 40 years being terrified of dietary fat, right?
Right, the low-fat craze ruined our metabolism.
It really did. Whole-fat dairy is what provides the caloric density and the complex lipids that actually signal the brain that you're consuming a substantial meal. It slows gastric emptying.
Okay, so we have a clean, dense, creamy base. Layer two is the flavor and the natural sweetness.
Yeah.
The fruit. Brecka suggests taking a solid fistful of organic berries. Raspberries, strawberries, blueberries, blackberries. And he makes a really interesting biological distinction here regarding the glycemic index.
He does.
He notes that fruits ending in the word berry are generally the optimal choice. Why is that?
Well, the cellular structure of berries is unique compared to a tropical fruit like a banana or a mango. Berries have a massive ratio of skin and seeds to pulp.
Okay.
That means they are packed with fibrous structures and antioxidant polyphenols. Because of that fiber matrix, the natural fructose is released incredibly slowly during digestion.
So you get the sweetness and the flavor without the blood sugar roller coaster.
Exactly.
Perfect. Layer three is the crunch and the healthy fats. For this, Brecka recommends tossing in a handful of organic raw pistachios and a sprinkle of pine nuts.
Yes.
And again, if you or your kids still need that hyperpalatable sweetness, the final layer is just a teaspoon of our old friend, monk fruit extract.
But there is one specific, highly functional ingredient Brecka highlights for this bowl that demands its own deep dive.
Oh, yes.
Because it fundamentally alters the nutritional payload of the meal, hemp seeds.
Yes, the nutritional profile of organic hemp seeds, as detailed by Brecka, is honestly hard to believe until you look at the math.
It's staggering.
He breaks down the macros for a single tablespoon. In just 1 tablespoon of shelled organic hemp seeds, you receive 14 grams of fat, only 2 grams of carbohydrates, just 1 gram of sugar, and an astonishing 10 grams of protein.
10 grams of highly bioavailable plant-based protein in a single spoonful. It is incredibly dense.
This is almost unparalleled.
But the sheer macros aren't even the most important part. Brecka focuses intensely on the type of fat present in those seeds.
Right.
He unpacks the critical, delicate ratio of omega-3 to omega-6 fatty acids in the human body.
This feels like a concept that gets thrown around a lot in health circles, but it's rarely explained well. Why does this ratio matter so much?
It is a vital piece of evolutionary biology. According to Brecka, the ideal biologically appropriate ratio of omega-3 to omega-6 fatty acids in human tissue is 1:1.
1-to-1, perfect balance.
Perfect balance. For millions of years, our ancestors consumed a diet of wild game, wild-caught fish, and foraged plants, naturally maintaining this 1-to-1 equilibrium.
So what happened?
The Industrial Revolution of our food supply. Modern agriculture became heavily reliant on cheap, highly processed seed oils. Soybean oil, corn oil, sunflower oil, canola oil.
The same ones in the cereal.
The exact same ones. These oils are absolutely massive sources of omega-6 fatty acids, specifically linoleic acid.
Okay.
Brecka states that because these oils are in virtually every packaged food, restaurant meal, and commercial salad dressing, the standard American diet has skewed this ratio disastrously.
How bad is it?
Most Americans currently sit at a ratio of anywhere from 1-to-25 to 1-to-45.
We are consuming 25 to 45 times more omega-6 than omega-3.
Yes.
Why is that physically dangerous?
Because of how these fatty acids behave at a cellular level. You can think of omega-3s and omega-6s as competing for the exact same parking spot in your body.
Okay, a parking spot.
It's a specific enzyme called delta-6 desaturase. When omega-6 gets the parking spot, the body uses it to synthesize arachidonic acid, which creates highly inflammatory signaling molecules.
So it turns the body's immune response on.
Yes, which you need if you get a cut or an infection.
Exactly. Acute inflammation is necessary for healing.
But when omega-3s get that enzyme parking spot, the body uses them to synthesize anti-inflammatory molecules that turn the immune response off and actually heal the tissue.
Oh, I see.
Because modern humans are flooding their system with 40 times more omega-6, the omega-3s can never get a parking spot.
The lot is full.
The lot is always full of omega-6. The result is chronic, systemic, low-grade inflammation that never turns off. It damages blood vessels, irritates the gut, and inflames the brain.
Wow. And that is exactly where the hemp seeds come in.
Exactly.
Brecka explicitly highlights them as a crucial, non-fish-derived, incredibly dense source of heart-healthy omega-3s, specifically alpha-linolenic acid. By throwing a tablespoon of hemp seeds onto your morning yogurt, you are actively introducing a massive wave of omega-3s to fight for those enzymatic parking spots. You're pulling your biology back toward that anti-inflammatory 1-to-1 balance.
It is cellular medicine in a breakfast bowl.
So let's zoom out here. What does this all actually mean for you, the listener, trying to get out the door on a frantic Tuesday morning?
Yeah, let's bring it back to practical application.
When you look at this entire lateral shifted bowl, the dense A2 whole-fat Greek yogurt, the low glycemic fibrous berries, the crunch of raw pistachios and pine nuts, the sweetness of monk fruit, and a heavy anti-inflammatory payload of omega-3 hemp seeds. This sounds less like a quick snack and more like a carefully engineered energy payload.
It is a perfectly calibrated nutritional matrix. If we synthesize why this specific combination of whole foods works so miraculously well physiologically, it hits absolutely every required marker.
Even the sensory ones.
Especially the sensory ones. From a sensory perspective, it is a triumph. It is crunchy from the nuts, sweet from the monk fruit, mildly salty, incredibly creamy and cold. It is deeply satisfying to eat.
It hits all the hyper-palatable texture notes you want from a processed neon flip yogurt, but it does it entirely through natural architecture.
Exactly. And most importantly, from a metabolic perspective, the combination of the high protein from the yogurt and hemp seeds, the complex healthy fats, and the low glycemic nature of the fruit entirely prevents the insulin spike.
You don't get the flash flood of glucose.
No. You get the slow, steady drip irrigation of sustained energy. This specific lateral shift keeps you and your children genuinely satiated for hours.
Actively preventing the cycle of mid-morning brain fog, sugar cravings, and constant snacking.
You are fundamentally changing your body's fuel source. You are moving from burning highly combustible, cheap newspaper, the refined carbs and artificial sugars, to burning a dense, slow-burning oak log.
Which brings us to the ultimate synthesis of everything we have unpacked today. The core takeaway from Gary Brecka's entire framework isn't about slapping a trendy, rigid diet label on your forehead.
Well, maybe.
He isn't asking you to declare yourself strictly paleo or fiercely carnivore or keto or vegan.
The overarching philosophy is beautifully simple. It is entirely about eating whole food sources and fundamentally considering the distance from the food to your table.
Right.
As Brecka's framework suggests, the closer the food is to the soil, the less it has been chemically altered, heated, extruded, dyed, and fortified, the better it will interact with your biology.
It is such a clarifying, stress-relieving metric. You just have to ask yourself, how many factories, chemical vats, and industrial extruders did this food have to pass through before it reached my bowl?
That's the only question you really need.
And for you listening, we want to remind you of the ultimate promise that was made at the very beginning of this deep dive, a promise that this lateral shift framework effectively fulfills. You absolutely can rid your mornings of synthetic food dyes.
Yeah.
You can eliminate the metabolic traffic jams of fortified chemicals, the cyanide-laced vitamins, and the highly processed inflammatory seed oils.
And you could do it without breaking your family's grocery budget.
Yes, and without sacrificing a single ounce of the sweet, crunchy, satisfying flavors you genuinely love to wake up to.
It does not require a total life overhaul. It simply takes a few deliberate, educated swaps, replacing empty, engineered volume with functional cellular nutrition.
Which leaves us with one final lingering thought to mull over today as you look at your own kitchen pantry.
Okay.
Think back to that incredible bombshell about the commercial yogurt aisle. If a simple artificial bright dye, a synthetic chemical colorant added purely for visual marketing appeal, is biologically powerful enough to completely wipe out living beneficial probiotics before the spoon even hits our mouths.
Right.
What other invisible chemical battles are quietly taking place on our grocery store shelves entirely unnoticed?
It fundamentally forces you to look at the entire food ecosystem in a completely different light.
It really does. You start to realize that the muddy, confusing waters of modern nutrition aren't just murky by accident. They are engineered that way for profit and shelf stability.
Yeah.
But now you have the exact biological tools to see clearly right through them.